This is a demonstration of my continuously learning software engineer salary predictor. This project consists of a deep neural network trained on the 2021 Stack Overflow Developer Survey and a web application that takes details from the user, returns a salary prediction, and then periodically retrains the model based off these inputs. I will begin with a brief overview of the model building process before moving on to show how the application uses the model. There are additional details about the model building process in the Jupyter Notebook. I built the model on Google Colab using Google's GPUs. This notebook named model can be found in the analytics directory of my project. I began with pre-processing of the dataset. This includes converting many of the columns into integer values, simplifying the education levels, removing salary outliers, and removing or filling in missing values. This is all handled in the common.py file in the analytics directory, and you could go through this to see a little bit more specification how I did that. And then a preview of this resulting data set can be seen here. Note that the education level, country, dev type, and languages have worked with columns still need to be encoded. I started with a basic baseline and worked up towards more sophisticated models. My initial baseline was from fitting some of the basic features to a pre-trained linear regression model from Scikit. With years code pro, age first code, and age, the model had a mean absolute error of about 35,000. After adding countries, the linear regression model improved to about 25,000. I continued to progress in this way, adding more features and starting to build a neural network with Keras. For my final model, I need to encode all the features as well as save the encodings to use later in our application. This is what I'm doing here. I'm doing this with ed level, country, dev type, and the language columns. After encoding them, I pickled them and put them in cloud storage. Our server loads this to make predictions and form training inputs for our retrainer. Here I'm building the final model. The build model function takes hyperparameters as an input and gets passed into Keras Tuner to find the best performing combination of parameters. And here is the result of that. After finding the best hyperparameters and training the model here, we have a final mean absolute error of about 20 or 21,000, which is about 6% of our maximum salary and lower than my target of 10%. So I'm pretty happy with the results. In order to make the input, we'll need to transform the encoding columns with our saved encodings. That's what we're doing here with the make input. This demonstrates how we can do this, and this is basically what I'm doing on the server when making the prediction and returning it to the user. Finally, we need to save this model so that we can load it into cloud storage and load it on our server. Now I will demonstrate how the web application works. I will show how the user can enter their information into the form to get a prediction from our model, what initially happens with it, and how it gets retrained. So I made a manual test script here while I was verifying everything in production. This is what I'll run through to demonstrate the application. So to start, we can look in the database and look at the predictions. This is the predictions inputs table, and it is empty. We'll look in Google Cloud Storage, and this should be empty as well, other than the initial encodings and model. This is our base model, so we're at a base state at the moment. Now we can go and make a few inputs. So I have a form field out here with basically entry level front-end developer sort of details, JavaScript and HTML are the languages, and put a salary of $90,000 and grant permission to save so that we can retrain it. This shows about the prediction of about $64,000, and we'll make a couple predictions. That's 2 is the minimum needed to retrain. In reality, you want to set a limit that requires more, but just for our purposes, we'll retrain with these 2. So now we can go back to the database, and we see our inputs here, and and note that the train column shows as false for these. And our retrainer is a cloud function written in Python here, and it gets triggered by a cloud job. Every 24 hours, this job publishes a message to a topic which the function subscribes to. When the job runs, the function runs. We can also manually run it now. We can look at the logs. This shows history of the function executing. It's a log that shows that it starts. There's some manual runs in here, but you can also see these right here show it running at the same time every day. So we can just update this to see what's going on. Function execution started. So the retrainer interfaces with the database via the API exposed on the server. When it's initialized, it loads the latest model from cloud storage. Then it gets the untraded inputs from the database. The server encodes these inputs so that our model can make sense of the country, developer type, and language. It fits the additional data to the model with an early stopping callback. And when it's done, it saves the new model to cloud storage, marks the inputs as trained, and triggers the server to refetch the latest model. And we can see that it is completed here. So we can go back to our database and look again at our inputs. You can see they are trained, marked as trained. Can look for the new model here in cloud storage. And there it is. It has triggered the application to update with the newest model. So we can go back and we can enter the same information here. And I'll pick HTML and CSS and JavaScript. And we don't even need to put in a salary this time. And we can see that the salary has changed. It's about 78,500. So this verifies that we have retrained the model and that the application has switched to the latest one.